Hi guys, salut les gars. Welcome to Mathman channel. Bienvenue sur la chaîne de Mathman. Today it's Basic Math episode 18. Aujourd'hui c'est maths de base épisode 18. So on the episode 17 we finished with this. When you get t of x equals a times x to the square b times x plus c, you can write it like this: a factor x minus alpha to the square plus beta with alpha equals minus b over 2 times a and beta equals minus b squared 4 times a times c under 4 times a. Okay, so let's have a look about what we can do with this. We can do this. Here it is: A, B, C, okay, and let's use alpha equals minus b over 2 times a, and let's beta equals minus b to the square minus, b to the square minus 4 times a 4 times c over 4 times a. Okay, and now let's write t of x equals a times x minus alpha to the square plus beta. Here we go. So let's try this, and let's try that. We can observe that x equals alpha is a symmetrical axis of the parabola, and y equals beta is the line of the summit. So if a is negative, this summit is a maximum. If a is positive, it's a minimum. Okay? And we know that there is a symmetrical axis. So this canonical form helps to see that. Donc la forme canonique, ça sert à savoir quel est l'axe de symétrie et quel est le sommet de la parabole. Okay, so now let's compute more by using this. Delta equals b to the square minus 4 times a times c. So what we can write is this. We can write this. So what we can say is, if delta is positive number, we can write that delta is equals to square root of delta to the square. So that means delta over 4 times a to the square is equals to square root of delta under over 2 times a and the whole fraction to the square. So why we do that? We do that because we can say that here we've got a factorization, because we've got one square minus another square. So we can use this formula. A times, sorry, let's use some color. A plus B times A minus B equals this guy go to this guy and then to this guy without forgetting this sign. So we've got A times A, it's A to the square. A times minus B, it's minus A times B. Then we've got this guy go with this guy and with this guy without forgetting the sign. So we've got plus B times A minus B to the square. But A times B is the same as B times A, so we can cancel them. So we've got A to the square minus B to the square. So here we have this part minus this part. And we can do the same computation. So here we go. We can write T of x equals A times x plus B over 2 times A minus square root of delta over 2 times A times x plus B over 2 times A plus square root of delta over 2 times A. So we can continue this calculus and we can have x plus B minus square root of delta over 2 times A times x plus B plus square root of delta over 2 times A. But we can say, okay, that's finished, but we can manage this in a way that can looks to you kind of weird at the first time, but if you look at more, you will see that will be convenient. So let's do this. Let's say it's x minus B plus square delta over 2 times A, and here it's x minus B minus square root of delta, and we can do this x minus x1 times x minus x2, with x1 equals this guy and x2 equals this guy. And we've got some property with these roots. We can look that x1 plus x2 equals minus b plus square root of delta over 2 times a plus minus b minus square root of delta over 2 times a. So we've got the common denominator, it's 2 times a, and we've got minus b plus square root of delta minus b minus square root of delta. Oh, we can cancel the square root, that's fine. And we've got minus b, it's minus 2 times b over 2 times a. Oh, we can cancel these guys. So we've got a first thing that x x1 plus x2 equals minus b over a. Oh, it's a kind of 2 alpha indeed. Okay, that's the first trick that we can observe. We can do the product of them, and we can observe that we've got minus b plus square root of delta over 2 times a times minus b minus square root of delta over 2 times a. So we've got a plus b times a minus b. Oh, that's a remarkable identity. Yes! So we can do this. It's equals to minus b to the square minus square root of delta to the square over 4 times a to the square. Okay, so that's b to the square minus delta, but delta equals b to the square minus 4 times a times c. So we've got x1 times x2, x1 times x2 equals b to the square minus b to the square minus 4 times a times c over 4 times a to the square. So we've got b to the square minus b to the square plus 4 times a times c. So we can cancel b to the square. Here we go. So what's the remainder? It's x times 1 times x2 equals 4 times a times c over 4 times a. So we can cancel the 4 times a. And we've got c over a. So let's summarize what we've seen. We've seen that if delta equals 4 b to the square minus 4 times a times c is a positive number, then we have x1 equals minus b minus plus square root of delta over 2 times a, and x2 equals minus b minus square root of delta over 2 times a, and we've got x1 plus x2 equals minus b over a, which is equals to 2 alpha, and we've got x1 times x2 equals c over a, and we've got a factorization of t of x. T of x equals a times x minus x1 factor x minus x2. So if delta equals 0, what happens? If delta equals 0, we've got t of x equals a factor plus b to the square. That means x equals alpha. That's as simple as this. And if delta negative, then we cannot find no real solution. T of x remain like this. So it's a sign of a. That means, because this guy is a positive number, delta is negative, but you've got a minus here. So this guy is positive number, so it's a positive number. This is a square, so that's a positive number. So we've got positive or even 0, and we've got the sign of a, because that's positive number times a, so that's the same sign as a. So a times t of x has got the same sign. So the product is positive. Okay, so here we go. We can have a recap. We've got this. First case, delta positive number. Second case, delta equals 0. Third case, delta is a negative number, and we've got a positive number, a negative number. We don't have any other. Let's do this. More space. Okay, first case. What we have is delta is positive, so we've got two roots. So we've got this, for example, and we've got a symmetrical axis. Let's say this, for example. A is positive, so we've got a minimum. So that means the curve is like this. Okay, because here you've got x1, x2. So let's suppose we have a number between x1 and x2. Okay, we've got the factorization. T of x equals a times x minus x1 times x minus x2. If we've got a number between x1 and x2 is greater than x1 but lower than x2, so x minus x1 is a positive number, x minus x2 is a negative number. So the product is a negative number, so the middle is when you multiply by a, it's a number of the opposite sign of a. So if a is positive, this part should be negative, and which is the case. Okay, that's why we have a minimum when a is positive. Okay, now if we've got delta equals 0, that means we've got t of x equals a factor of x plus b over 2 times a. So it's the same sign as a. A is positive, so we've got a positive curve, like this. We've got a symmetrical axis, and then we've got this, like this. Okay, and if delta is negative, we've got the same sign as a. A is positive, so it's positive. We cannot factorize it, so we have to keep like this. We've got still a symmetrical axis, let's say from here, for example, but we never touch the x-axis. That's this situation. Now, we still have delta positive, but we've got a negative, so if we do the same calculus and same analysis as this case, we will see that the opposite sign of a is negative, so we should have a maximum. Let's say the symmetrical axis is here, and we've got the curve like this. We've got x1 and x2. Okay, so here, let's say the symmetrical axis is over here, for example, and we've got a negative a, so we've got a negative curve, like this. And here, we've got, let's say, symmetrical axis is here, and we've got a negative curve, strictly negative curve, like this. We've got 6 cases for the quadratic function. Now you know exactly precisely what you have to know with quadratic function. See you tomorrow.